Hello, everybody. My name is Jura Arkhangelski. I'm associated professor in the Certers Laboratory in the University of Paris at Créteil, France. And here we'll show our research about combined Akima interpolation and deep learning LSTM method based on building energy efficiency prediction. So I will have an introduction. I will present this Akima interpolation method. We will present developed non-intrusive load monitoring long short-term memory method for IoT Internet of Things building data, his practical evaluation and conclusion. So the modern development of science and technology in the field of energy efficiency and building audit lead to an intermittent growing development of various Internet of Things objects. Currently, IoT sensors are very popular in the building sector due to the low price, high autonomy, up to several years, wireless, and ease of installation that do not require intervention in existing electrical circuits, also called non-intrusive. On the one hand, this allows to monitor the technological parameters of building and quickly respond to various incidents, reduce power consumption, thus increasing the energy efficiency of building and responding to the challenges of the world energy transition process. From the other hand, a large number of sensors with a large amount of often transmitted information create huge databases and information flows that cannot more be predicted manually by a person or by sample algorithm. So they will require modern big data processing technique specifically designed for IoT building application. And for this, deep learning neural network technologies are showing their good results in the processing of serial data, such as the energy consumption of building and its equipments. It allows to realize an automatic, in-depth analysis of this data with the ability to make predictions, classify them to find normal and abnormal energy consumption. For a good result, the technology requires preliminary measurement companies of this equipment and training of neural network. From this point of view, the main disadvantage of IoT sensors is that they cannot transmit data very often with the same time step. It is associated of restriction of the use of public frequencies of wireless technology, transmitting protocol, frequency congestions, and the data delay can be from 0,1 to 30 minutes depending on the type of sensors. Likewise, for the correction operation of the neural network, all input data must be brought to the same time steps, and therefore this research proposes and describes an original method of non-intrusive load monitoring through IoT building energy using Akima interpolation and deep learning learn short-term memory neural network. So about Akima interpolation, it was created in 1970s by Hiroshi Akima. He proposed a modification of the familiar cubic spline in order to get rid of unwanted outliers. It required only at least 5 points to build the interpolation curve and is based on the set of 3-degree polynomials assembled in the piecewise function of Akima method. So we have in general, we'll explain in general, so we have like data points set from P0, P1, P2 and next point till n-1 with the appropriated parameters U0, 2, 1, 2 and respectively that satisfy this equation 1. And the curve R from this parameter U of Akima spline is represented by this equation where we have A, B, C, E, D coefficients. So to calculate these polynomial coefficients, it's needed to find the first derivative of R from UE and R from UE plus 1. So And also first derivative of UE can be replaced by S UE, the approximated value presented in this equation. And we can see that he not depend of the width of the interval and depend on the 5 points of data, like 2 point before and 2 point after. To calculate, so here we have equation to calculate this coefficient, and Akima interpolation is calculated very quickly because on the local method I use it. So this method gives good results for the value of the approximation function. He also returns exact estimate of the first derivative of the fitted function when the data points are uniformly distributed, and shows a good result in the data series interpolation, such as the IoT data of building energy sensors. And here we show like comparisons that we did with like here in blue points we have initial data points who like with different time step, and we compare with the linear polynomial spline from different orders and Akima method. So we have Akima in green here, like generally visibly we can see that it's fulfill the normal curve of IoT sensors. And here it's another example. We can see that in some cases, when it's not often, the data points are not often, linear like cut the data, and only Akima have like a smooth following the data curve to interpolate it. So now we will present our non-intrusive load monitoring long short-term memory method for IoT building data. So he used Akima interpolation and deep learning neural network, and consists of two stages. So the first step of method is to train a neural network to recognize the individual equipment chosen for non-intrusive load monitoring, like equipment X. And this stage data from required IoT sensors, like if you look graphically, so we have all building IoT data profiles with different time steps, like general consumption, equipment consumption, inside temperature, outside temperature, with also added measured real data of our equipment X, go to Akima data interpolation method, and we obtain a resampled combined IoT data set with unified time step. And he go to the long short-term memory network for training. So the second step, as soon as the training process is completed, the method proceeds to the second stage, which is to generate a profile of this equipment X using the training the proposed method. And the advantage we can see that we don't know needed here the real measurement of equipment X, because we only have like a current measurement of other parameters, and this go to the long-term neural network which already trained, and we can generate this equipment load profile. So for this is the idea of non-intrusive load monitoring. So we don't need to measurement, but thanks to other equipment curves, we can generate this load profile. So advantage of this method is one trained network no longer needs to be trained. The training may take some time depending on the amount of data, and training networks can constantly generate a profile of this equipment in almost instantaneous. So practical evaluation, we will use a multi-purpose concert hall and media library in Paris region. Like we have media library, concert hall, and multi-purpose hall. This building heated and cooled by heat pump using the Earth's geothermal energy, with a big capacity. Condenser is about 500 2003 kilowatt, and the evaporator, so the cold, is about 410 kilowatts. This heat pump don't have frequency control and only two compressor speed. So we can see here his rated power is about 135 kilowatt, and compressor stops and start from one speed to another, bring significant fluctuation in the consumption curve. So here we can see in blue line is the heat pump consumption. We can see this fluctuation. In yellow line is the concert hall energy consumption, green line media library energy consumption, and the orange the total consumption. We can see building consumption is very oscillated due to the heat pump, who is only two speed, who is like second first speed of compressor. So we also add to add the temperature sensors data, because it's related to the heat pump, because heat pump produce hot and cold, and related to the outside temperature. We can it's correlated data. So in our case, input data for the non-intrusive load monitoring neural network will be the total energy consumption of the building, energy consumption of the media library, energy consumption of the concert hall, and energy consumption of the heat pump only for the training period, and also the temperature sensor data that we can see inside and outside. It was a winter day in December of 22. So here we can see the result of non-intrusive load monitoring. So in blue line, we have the real measurement that we measure from this equipment, and the orange is the generated by neural network, the heat pump consumption curve. So we can see it's like very similar. Our method can reproduce accurately the heat pump energy consumption graph. And to analyze more deeper, we use the mean average error and mean absolute percentage error indicator, and we can see that about 20% mean absolute percentage error about 20%. And we can conclude that it's very good results, but because the heat pump will like very have this oscillation, who is very arbitrary fluctuation, so it's for deep learning, it's neural network. It's very difficult to predict them, but it's also we can see that very good also results to recognize the consumption profile of this equipment. So, this research present, in conclusion, this research presents the original method of non-intrusive load monitoring of building equipment, energy consumption, which is specially adapted to Internet of Things building energy sensors. So this method allows to see the consumption of individual equipment using the data of the total energy consumption of the building through the use of neural networks. The proposed method of non-intrusive load monitoring is based in the Akima Interpolation technique and deep learning neural network. The feasibility and effectiveness of proposed method were confirmed on the real data case of multi-purpose building with installed IoT sensors, and subsequent in-depth analysis of practical evaluation showed the correspondence of the received data from our method to a real measurement with the mean average error percentage error about 20%, and thereby this method allows to reach a new level of building energy supervision and management. So thank you for your attention. I will be pleasure to answer on your questions.